So in today's session, we've got a fantastic panel of speakers from some key companies and university research groups who are working on the Hyperloop concept. In this session, we'll be exploring whether Hyperloop is a reality for future passenger travel. We'll be hearing about the developments in the Hyperloop sector so far, exploring the regulations and legislation to understand if there's barriers to moving forwards. And we'll also understand how Hyperloop networks can be integrated into city transport landscapes. The session will consist of 4 15-minute presentations, followed by some time for Q&A. So please do send through questions for the session so we can have a really lively discussion at the end. So let's dive into the presentations. Our first presentation today is from Eva Radzkowska. She is the president of HyPed. HyPed is an award-winning team of students at the University of Edinburgh dedicated to developing the Hyperloop concept. So welcome, Eva.
Hi, thanks Rosalind for the introduction. Let me just quickly share my screen. Okay, so thank you very much for inviting me, and thank you so much for coming here to listen about Hyperloop. Before we get started, I'd like to say a couple words about me. As Rosalind already said, I am part of HYPE, which is University of Edinburgh Hyperloop team, and we have been part of SpaceX competitions before, so we've gotten to the final of the 3 past SpaceX competitions. We've also been the finalists of Global Hyperloop 1, Virgin Global Hyperloop 1 in 2017. So we planned our route from Edinburgh to London. And more about me, I'm a 5th year mechanical engineering student at the university. I'm from Poland originally. I've been in 4 different countries along the way before I got to Scotland. And just specifically about me, I'm interested in sustainable solutions, which explains a little bit more about why I'm here. Talking about Hyperloop to you, and leaning a little bit away from STEM, I'm also interested in learning languages and maps, which also explains the giant map behind my back, if you can see my video at the bottom. So jumping into the presentation, the 3 main things I want to talk about. First of all, I wanted to introduce the Hyperloop to any one of you who hasn't heard about it before or is only vaguely aware about what it is. So just talk about the principle of operation. Then I'll touch on the problems and solutions of Hyperloop, but I won't go into too much detail into this because I'm sure Mars, Andres, and Diana will go on into more detail about the solutions that their companies have for the problem. So I'll just give a brief overview about it, because afterwards I'd like to focus a little bit more on the student perspective of things, which is basically where I'm coming from and what my expertise, you could say, lies in. So jumping into Hyperloop. What's the deal about Hyperloop? How does it work? Basically, you can explain Hyperloop to be an ultra-fast bullet train using the principle of magnetic levitation in a vacuum tube. So because it's using magnetic levitation, it avoids the problem of friction, and because it's in a vacuum tube, it avoids the problem of air resistance. So basically, getting rid of these 2 problems not only makes the Hyperloop able to go really fast, so obviously faster than a train. The final design of Hyperloop, the aim of it is to reach subsonic speeds. So it's basically the same speed as a plane, or around the same speed as a plane, but it's much more ecological due to the fact that, again, it's much more energy efficient due to the avoiding the losses, the energy losses that are connected with friction and air resistance. But also additionally, it will be by default powered by electrical means, which means that it could be fully powered by renewable energy sources, and therefore be even carbon neutral, a carbon neutral mode of transport.
Ava, I'm very sorry to interrupt you. This is Craig here. We cannot see your slides, so if you wouldn't mind sharing your screen, that'd be great. Thank you.
Yeah, of course. Can you see it now?
Yes, that's perfect. Thank you.
Okay. Yes, so let me just go quickly back to the agenda just so that you can see it. So it's Hyperloop problems and solutions, a student perspective. So it's a bit of a, so that you have it in your mind. And yeah, and these points are just what I've been talking about. So apologies for not being able to share my screen before. But yeah, but basically going back to the topic, how did Hyperloop start as to be out there? It has been released as a white paper as a joint effort from Tesla and SpaceX in 2013. And since then, it's been really popularized by Elon Musk. But it has to be said that the concept as Hyperloop has been known for quite a long time. The first mention of a system similar to what we, maybe a bit different than what we are aware of Hyperloop as of now. But basically a train, a levitating train in vacuum, has been mentioned in actually 1799. So it's been a while since it has been, the talk about it has started. But the majority of the research has been happening in the past decade, which means that it's been extensively researched by students, by academia, by industry. So from different fronts, the Hyperloop has been extensively looked at in the past few years. And this obviously provides both a positive and a negative to the whole design and to the whole technology, just because of the fact that it is one design, one concept that is worked on by multiple people. For one thing, you have multiple designs and multiple ideas, which obviously in a design stage that's, you know, for a system that's very innovative, that's really great because you have so many different designs that you can then assess, and then you can merge into, you know, one final design or a few final designs that are really good because you can you have many to choose from. But at the same time, it introduces the difficulty of having many designs and actually, you know, trying to integrate them all might be a bit of a difficulty, which I'll talk about it a little bit more later. The reason that Hyperloop is such a big deal, and the reason why Hyperloop is something that we really want to research, is there are two reasons for it that are intertwined. One of them is that the demand for travel is increasing, and this is both business travel, commuting, leisure travel. But at the same time, the people that want to travel, they are more and more environmentally conscious about how they travel and the way they travel. And they want to get from place A to place B as fast as possible, usually, but also they want to be able to do it in a carbon neutral way or in an environmentally friendly way. And Hyperloop seems to be the solution here, and is a really good solution to that problem. So to summarize how a Hyperloop could look like in a real life situation, in a real city, I have a little presentation here. This is an animation that we produced for an online course that I'll mention later on as well. Hopefully it will give you an idea if it plays. Okay, I don't think the animation wants to cooperate, unfortunately. Yeah, sorry about that. More technical difficulties. I'm not sure if I'd be able to play it. Yeah, sorry about this. I think that will be another thing that has to be passed on. Yes, so basically you can see here, maybe even in this image, just slightly less so than I wanted to show you, is that there is a concept that you can basically integrate a train in a station. You know, basically the Hyperloop would approach a city, and in a similar way that a train would approach a city, you would have a station close to the city or near, or you would integrate it more, you know, there's different concepts. You could integrate it in a city, connect it with a railway connection, or also there's another concept that you could have it connected more with the airplane stations that you have, or airports that you have outside of the cities. So sorry for this difficulty that it's not wanting to cooperate, but basically what hopefully, you know, at least I could describe to you what I was going to show you. And that what I wanted to say as well is that, you know, obviously it's very easy to make an animation and try to illustrate what it's going to be like potentially, but it is quite difficult to actually put it together and actually make it happen in reality. There are multiple aspects that come into play when it comes to planning a Hyperloop system and integrating it in the society that we live in at the moment. And the ones on the screen here, safety, legislation, the economical aspects, technical aspects, they're only a few of the many, many aspects that have to be considered. And what's important to note is that all of these topics have extensive answers. So there's not just one answer to it. And the reason for it is partly, you know, the aspect that I just mentioned, which is that many companies have been working on it independently, and they all have a different, or many companies or many academics, many student teams, and they all have a different idea about what a solution to a specific problem is. For example, I'd like to, as an example, I'd like to take the economics question, which is how much the ticket prices would be, or how much will this actually cost? And it's a really difficult question that will be, the answer to it will depend on what kind of technology as a team, or as, you know, as a team developing this technology, what kind of components you use. So for example, you can use either an active or a passive propulsion system in a Hyperloop. And what that means is that you can either have, if you imagine a Hyperloop consisting of a pod or a capsule that moves, an infrastructure, which is the tube, you can either have a propulsion system on the pod, which you can have linear induction motors or linear synchronous motors, for example, that propel the actual pod. And if a propulsion system is inside of the pod, then the infrastructure can be quite passive, can be literally just you know, pieces of metal or rail, and there is not much cost associated with that. However, you can go the other way as well. Another direction for it would be to have an active system on the actual infrastructure, and then the pods themselves will be passive. So then the pods will only have, for example, magnets in them, and then will be in general not requiring any power, but then the power will be on the outside, so in the infrastructure. So basically these two, you can see here that these two approaches really influence the capital costs of building the infrastructure. And that will obviously also then influence everything else. Additionally, on top of that, what's important is whether the Hyperloop system as a whole is considered to be something separate or something integratable with what we already have. For example, there is a project back home in Poland that Hyperloop could be integrated into the current railway systems, and it could be phased in, you could say. So the investment would be spread out. So first of all, the current railroads or the current trains would be transferred into bullet trains, then into maglevs, and then gradually, you know, the vacuum tube will be also introduced in the current railway systems. So if you think about it this way, then it will be a different distribution of cost than if you were to invest in a whole network all at once of a brand new Hyperloop concept, right? So these, as I said, there isn't a specific solution to it, but there are many aspects to consider in each of these questions. So having discussed a little bit the concept of Hyperloop, I wanted to tell you a little bit more about what student societies or about student teams that work towards developing this technology, what they actually do, and how we help make it a reality. So us specifically at Hyped, and I think a lot of teams in Europe and outside of Europe can also relate to that. We first of all develop a pod. So we design a pod and we build it to demonstrate the technology that is Hyperloop. So about the propulsion systems, the braking systems, everything like this, and we try to make it a reality and showcase how fast it can go and what it actually can do. And on top of that, as Hyped, we are also researching the possibility and the different aspects of introducing Hyperloop in the society, and I'll chat a little bit more about it in a second. And we also want to put the idea of Hyperloop out there and teach people about it and make sure that everyone is aware. So basically, these three aspects are very common in student teams, and it's something that I think brings us together as well, as you know, young people that work towards something that they really believe in. And I think that also is an important aspect of the student teams, because a lot of our members at Hype specifically, but also in other teams, have gone on to form their own either startups for Hyperloop specifically or something connected with Hyperloop. So I think Mars can also relate to this, the speaker after me, because I know he's been associated with a team like this before. However, in general, you could say that, you know, as teams like this really do drive people, young people, to work towards Hyperloop as well. So the technical team, that just to give you an idea of what the technical team works on, this is our pod that we designed last year. And it's a pod that doesn't have any people inside, so it's not a passenger pod. It's just to showcase the technology here. So yeah, the propulsion system, the braking systems, and everything of the sort. And we are planning to build this pod this year, as we have been the operations have been paused last year because of coronavirus, unfortunately. Then, as I said, the research team is working on introducing the idea of Hyperloop in reality, and our team specifically, because we're a UK team, we are looking at introducing a proposal for Hyperloop in the UK. We have already, as I mentioned, taken part in version Hyperloop 1 Global Challenge, which was about planning a route in London. So we thought of a route from Edinburgh to London, and we want to bring it forward by introducing a proposal for Hyperloop in the UK. So hopefully that is going to be published in the form of a paper this year. So that's very exciting, something very exciting to look forward to from our research team. And the outreach team, as I mentioned, they're attending conferences and spreading the word, but also this year we're aiming to publish an online course about Hyperloop on an open platform, so to reach even further and to make everyone even more aware about Hyperloop and how to make it a reality. So this being said, and as I said, this is specifically about Hype, but I do believe that a lot of other student teams do contribute to it in the same way. I wanted to quickly talk about next steps from a student perspective of how things can go forward and how things can move forward for Hyperloop. What is needed, as I mentioned a couple times already, is an integration of ideas. It's establishing a standard between all the different ideas that have been formulated around the globe, popularizing Hyperloop, because not everyone is aware that Hyperloop as a solution is something that we can introduce, and it's progressing very quickly, and the stages that we're at when it comes to technology are much further than some people are aware. From what I've heard people saying, for example, when we meet people, they are not aware that it's progressed as much as it has so far. And we do need more talk about it to spark interest in Hyperloop as well. And we as students are also feeling the need for this. So taking the matter in our own hands, I would say, there are 4 teams in Europe, including Hyped, that we have started to put together something to join all of these things that I just mentioned. And we are organizing a European Hyperloop Week, which has not been officially announced yet. So this is a little bit of a announcement about it, but this is, I think, very important because it will integrate the industry, the academics, the students in 1 week in the summer. And it would also introduce, the teams to each other. It would introduce the industry to the teams, and hopefully it would be some kind of an integration that can be then later used again year after year to make sure that the Hyperloop community basically forms and continues to strive. So if you're interested at all, there is more info at hyperloopweek.com, and we as students are really keen to push this forward and to make Hyperloop happen. So I'm really excited about this, and this will be it from me that I wanted to mention, and I'll pass you on back to Rosalind.
Thank you very much, Eva. It's great to see, such enthusiasm from student groups, and also the fact that student groups have commercialized. There's a few examples of where that's happened, so it's really, really good. I now introduce you to our second speaker. That's Mars Goose. He is the co-founder and CEO of Hard Hyperloop. Hard Hyperloop is a Hyperloop developer based in the Netherlands. The founders of Hard were also previously part of the award-winning Delft Hyperloop University team. Thank you.
Thank you, Rosaline, and also thank you, Eva, for your presentation. And it segues nicely into mine, since we were actually one of the teams that won and then turned into Hard Hyperloop. As you can see, I'm already riding in a Hyperloop now from Amsterdam to Berlin. Of course, that's a joke. That trip would be way too short to be able to give this presentation. But let me also start sharing my screen and name you all welcome to the world of Hyperloop. What I would like to present today is a little bit of the vision of what we're working towards, what kind of routes or what kind of connections that you can think about when we're talking about Hyperloop, the steps that have been taken for standardization, and gives a glimpse of the roadmap that we have ahead to bring Hyperloop towards realization. But of course, I would like to start with giving you a little bit of a taste of our vision, which is that in 2050, we can travel over a continent with the Hyperloop in the same way that you can now travel through a city with the metro. We really believe in making a world where you're free to go wherever and whenever you want to be, and make this accessible through technologies like the Hyperloop. And analogously for cargo, we want to make sure that the continental supply chain is connected within several hours, so that we can really turn a continent into a single market. For example, that Europe is really a single market, that from any warehouse within a continent, you can supply the entire continent within a day, which will of course completely redefine the way in which the logistics works, how supply chains work, and also how companies can supply products to their customers. Now, if you look at what the trends are in transportation, it is there's a little bit of a conflict in interest. On the one hand, we of course have climate change, we have congestion, so there's a want to reduce those. But on the other hand, there's also the trend that the demand for passengers and cargo transport is tripling towards 2050. Now, this number is from pre-corona, so that's when these estimations were done. So of course, we also cannot see in the future what exactly will happen here, but at least what you can see now is that the traffic jams have already returned, and also that cargo has grown even faster now in this period. So this is definitely a trend that we expect that still proceeds. And also estimated is that it will require over 69 trillion euros worldwide to be able to cope with this growing demand, which is of course an unimaginably high number, and this includes everything into ports, airports, roads, railroads, and so on. But this is the estimated number that needs to be invested into infrastructure, transport infrastructure in general, to cope with this demand. What we believe is that if we're going to do these kinds of investments, you need to do that into future-proof infrastructure. And that is infrastructure that is efficient in costs, both for implementation and in usage. It's energy efficient, so little energy use, but also very low emissions. It needs to be efficient in implementation. This is by far one of the biggest issues to get infrastructure implemented. More than half of the costs are there because it's difficult to implement infrastructure. So making a small footprint is very beneficial. And of course, in the end, these systems also need to be competitive in both speed and in transport capacity. Because if you are not competitive in capacity, then you will never really have a decongesting effect on the current infrastructures. And these 5 points, what we think are crucial for future-proof infrastructure, these are exactly in which Hyperloop scores very well. So I won't go into the details of the technical part, but I mean, the most important ideas that link to the previous slides are that it's transferred through a low-pressure tube, which means that you have low aerodynamic losses and therefore very little energy usage. The system levitates magnetically and is propelled magnetically, which means that there's no wear and tear and very little maintenance. And thirdly, the system can be implemented above ground and underground. The tunnel is sort of already its own overpass and its own tunnel, the pipe, which means that it's relatively easy to implement alongside existing railway, alongside existing highways. And also the pipe itself protects the vehicles from the environment. So you don't have any problems with wind, rain, snow, no leaves on the track, which also decreases the maintenance costs. So this is where the Hyperloop really fits in with that future-proof infrastructure. And of course, we won't be replacing the existing transport infrastructure, and it will all be an additional mode. But if you look at approximately what a market would be for Hyperloop, well, there's now about 1 million kilometers of rail in the world. And if you look at, for example, Europe, about one fourth of the entire rail network there is also identified by the European Commission as the core strategic network connecting the major cities in Europe. And we also believe that about one fourth of that rail network in the world, therefore, fits very well with what we're trying to do with Hyperloop as well. So that's a network of about 250,000 kilometers. And if you look at Europe, that would be a network that looks, or at least at the length approximately of what you see in the slide here. And to implement a network like this, the implementation costs are about 7.5 trillion, about in the entire world, right? So the whole 250,000 kilometers. So imagine, like I said on the first slide, we have to invest towards 2050 about 69 trillion anyway. Then if you look at it into that perspective, the total amount of investment into Hyperloop infrastructure is not even that large. It would be about 10%, but it would give you an immense amount of benefits vis-a-vis the other transport infrastructures that you could implement instead with those fundings. So what I want to focus on here is just to say, you know, this is not building a network like this is not out of the sort of range of funding that needs to be spent anyway. And it's also just an additional mode. It's not going to be the bulk of all the investments. Now I would like to go a little bit more into the use cases. So, you know, one big study that we've done, for example, is with Amsterdam Airport Schiphol. You might wonder what the reason is why an airport steps into a development like this, because an airport typically is for transporting through aviation. But there's a lot of benefits that I will go into now, and here you can get a little bit of an idea of what that could look like, what a Hyperloop station in such an airport would look like. It really gives a lot of the idea, like I said, of a metro system. You just go to the station, you get into the vehicle, and you go towards the destination that you want to go to. And this is the network that we looked at with Schiphol on aviation side. So basically connecting all the other major airports within about 600 kilometers as a first basis network. And this network by itself is already socioeconomically feasible just with the aviation passengers. So that means that we are using competitive ticket pricing, so no higher than the current prices you would pay for using aviation, and then also taking into account all the emission reductions and so on. Although the lion's share is simply just the financial parts of the ticket sales. But there's actually, and that's just looking at the aviation passengers, but there's a second type of passenger that's very interesting for this as well. And that's because we can make a difference on sort of two different scopes. One is you've got the sort of the international transport, like I just said, printed network. On the other hand, you can also use Hyperloop more as a public transportation system. And the reason for that is that it so drastically reduces the time between two stations. And with a Hyperloop system, it's possible to go from any location to another location in the network without having to stop at different stations in between. That you can also make extremely fast connections between other distances, almost sort of fusing cities together. And how that then works is if you look at the willingness to travel as a function of time, you'll see that you know, from 40 minutes onwards or so of travel time, it decreases very fast. But between 20 and 40 minutes of travel time, and even lower than that, there's a lot of people who are willing to travel. So that means that if two cities were now with conventional transportation, for example, with rail about an hour away from each other, and you make them suddenly 15 minutes away from each other with Hyperloop, and then add before and after transport, that you turn those cities almost into one socioeconomic entity. That is extremely good for both the competitiveness of the regions and for these agglomeration effects. So here I have some examples from this, also resulting from these studies from the Netherlands. And we're assuming here that there's a first mile and a last mile connection of 30 minutes as well. So that if the main transit is 30 minutes, that the total transport time is 60 minutes. That's the total travel time you see here in this graph. And just to give a few examples, for example, Groningen is at one edge of the Netherlands, and it takes about 150 minutes now in total, including first and last mile. This is something that no one really commutes. But with a Hyperloop, you can turn the total travel time to about 50 minutes. So that completely changes the way that you can look at a country. That regions that before were not connected suddenly turn into almost the same city. And on the larger scales, it's maybe even more interesting. See here, the travel time with rail, and this is high-speed rail, is over 200 minutes to go from Amsterdam to Düsseldorf. With aviation, it's not much better because you have a lot more first and last mile time. But with the Hyperloop, you can turn this actually into a commutable distance. So cities that were also internationally split up before almost turn into a different economic entity as well. You can completely look at a different way in which these regions have their competitiveness. So I think this is one of the most interesting aspects, besides just having the obvious case of, which I'll go into now, replacing air travelers, also completely redefining the way that the cities and spatial planning is organized. To now go into a little bit more into the aviation case. We have done a study looking at all the previous places where high-speed rail was implemented, where it took a large share of aviation, and looked at factors such as operations, service, travel time, and so on, to see how many people would choose for one or the other system. And if you would build this entire European network, with this model, we estimate that about 62% of all the trips would choose to go for a Hyperloop. And that means with about 10 times less energy usage with a Hyperloop than aviation's, that is an enormous impact also on the climate, on our climate goals. And as you can see here, this is the cruise speed that we've been using. Even with 500 kilometers per hour, you already have a larger share of the market for distances up to about, say, 2,000 kilometers, which is most of Europe, basically. If you go to 700 kilometers per hour, the modal shift is even higher. So you don't even really need to go to the 1,200 kilometers per hour that has been often touted for Hyperloop. Even with 700 kilometers per hour, you're already making such a huge difference. Now to finish off, just a little bit more about where we stand now and where we're going. Here you see the boy band with which we started Hart after winning the first competition of Delft's Hyperloop. This is the test track that is in the Netherlands, in which we can prove all the systems for levitation, stabilization, propulsion, and even a lane switch, which is very important to be able to get those network effects that vehicles can merge in and out of a system. We can prove all those technologies here in this test facility in Delft. Another very important part is that we very quickly realized that this should not be just one system, but in order to be able to achieve what I just said, that you have that European network and really be able to compete with aviation, you need to be able to be interoperable in the entire network. It cannot be the case that somewhere halfway, one pipe is a little bit bigger than the other, and that you then have to switch into a different system. That's going to completely destroy all the benefits that we've been trying to build up. So it's crucial. We now have a blank sheet of paper that we standardize and that we converge towards a single interoperable system. And right now, this official standardization procedure has been initiated, which means that Hyperloop companies that have been that have joined the standardization procedure are now, as we speak, working together to ensure that that convergence is there. And we also believe by certifying such Hyperloop system in Europe, we have a system that can be exportable worldwide and really be the basis of a global standards. So then, what are the steps that we're now taking to get to this world? Well, like I said, there's already a proof of concept. What we're now preparing is a cargo testing facility so that we can move towards, animations are not going well, but so we can move towards doing a cargo commercial demonstration somewhere along between 2023 and the end of the 2020s. And at the same time, perform all sorts of passenger testing at also the later phase of this timeline, so that you can learn so much from first doing a commercial application for cargo, going through all the hoops there, that that you can also go into passengers afterwards. And yeah, where we are right now is that we're basically finishing all the last work to be able to start building the European Hyperloop Center Groningen, which is a facility where we want to prove all the technical feasibility for a cargo system in preparation for the first cargo commercial route, and also to test all the passenger systems at scale. And crucially, I don't think you can see it very well here, but in the image you also see that we'll be doing a lane switch here, which proves that you can morph in and out of such a pipe. So just to conclude my story, here's a nice image that we found of the Roman road network. And back in their time, they were able to build about 400,000 kilometers of roads just by a single empire. And I always think that that's sort of a nice thing to think about. They built 400,000 kilometers of roads. Sort of between 1800 and 1900, we built almost 1 million kilometers of rail. And right now we are at the it's 2 minutes to 12, and right now we're there to start building the first steps for a Hyperloop network, so we can have an image like this also in 30 or 50 years from now. Thank you very much.
Thank you very much, Mars. Thanks for setting the context in terms of future transport demand and how Hyperloop could be applied both regionally and internationally. It's also good to hear that the Hyperloop developers are all working together to standardize the solutions, similar to obviously the kind of cooperation between the university groups too. Okay, so our third speaker today is Andres de Leon. He is the CEO of Hyperloop TT. Hyperloop TT is an American research company formed using crowd collaboration approach, and they are working to develop a transportation system based on the Hyperloop concept. So I'll pass over to you now, Andres.
Okay. Can you hear me? Okay, hello everybody. I assume that you can hear me now. So, can you hear me? Well?
Yes.
Yes, okay, perfect. Thank you very much. Okay, so thanks to the organization for bringing us here. I'm Andres de Leon. I'm the CEO of Hyperloop Transportation Technologies. I'm gonna share my screen to go in our presentation. Okay, so sorry, yes. Slides on. Okay, so like always, we're having some problems to get this. We're using the screen, but we are not being able to start the presentation.
Can you press the on slideshow on the left-hand side, play from start? Not working.
I'm like that, yeah, but it doesn't work. Okay. Something's happening. Yeah, that's where I am. Just give me one moment. So let's try to see if we can do it now. Slide, so play from start now. Okay, sorry about the delay. Okay, thank you for everybody to be here. We are very happy to serve with our colleagues of the different Hyperloop companies. I'm very happy also to have a representative of the students community. I'm Andres de Leon. I'm the CEO of Hyperloop Transportation Technologies. I've been okay, sorry, but something is happening now. Again, okay, good. So I've been with the company for more than 5 years, and and I'd like to give you our vision of what is Hyperloop about. Okay, first of all, let's talk a little bit about the opportunity. We believe that we have a once-in-a-generation opportunity to really change the way that we travel. I think that passenger transportation is ready for disruption. We have big gridlocks that cause big cost, congestion at the airports, limited velocity on the high-speed rail, on the average of the high-speed rail. So there has been attempts to improve this situation, but we haven't been successful to create some system that is really efficient. The problem is not only how this works, but also how it impacts our quality of life. Okay, inefficiency, noise pollution, time loss. Every single data that we see is telling us that we really need to change the way that we are thinking about the future of transportation. And of course, the cost of transportation, because also impacts to the economy. The air pollution cost is more than 66.7 billion is the total cost of air pollution in the European environment in 2016. We have a big problem with our actual rate system that is heavily subsidized by public subsidies. New York Metro, for instance, costs us more than 1.3 billion every year on subsidies, and like that, most of the areas of high-speed rail doesn't have economical viability by itself if you don't put together also the social viability and the cost of congestion, and of course, the current modes of transportation impacts the environment. CO2 emissions, air pollution, energy consumption. So I think that we are ready for a change, okay? But we are ready for a change, and we need to think about how we want to do this change. From Hyperloop TT, in our vision from the beginning, we wanted to create a system that, from the government perspective, was profitable and has a logical return of investment that allows the system to be fully financed by private money and doesn't rely on public subsidies. From the point of view of the users, we don't like to travel anymore. We travel because we have to travel, but we need to change the experience. We want to create a seamless experience. We want to create a system that is accessible. And of course, in today's world, you cannot even think about a system without taking in consideration the sustainability. So that's our blue ocean strategy, to create something that fits with the governance, fits with the user, and is sustainable. And the main principles of that system will be, how is Hyperloop? Let me put you a small video, and and you will see what is our thinking. Can you read it? Can you hear the video?
We can't hear it, but we can see it.
You can see it. Okay, so then I think that it's better that I stop it because sorry about it. Okay, so anyway, what defines the next era of human mobility? Okay, so basically for us, in our concept, we really need to develop a system that is high speed, is efficient, is profitable, is safe, is sustainable, and is frictionless and passenger-centric. And all of these are the main characteristics and the main elements that we have been working since the beginning, since the first moment that we started to develop the Hyperloop, being the first company that was formed to develop it. So why speed is important? Speed is important because break the limit of continental distance. Right now, there's a lot of studies that tell you that high-speed rail, if you are connecting cities in less than 2.5 hours, basically you take the demand out of aviation. But if it is more than 3 hours or 4 hours, nobody wants to be in the plane. But imagine a continent where people could go almost every continental distance in less than 4 hours. That would change drastically. And also redefine the urban landscape. We could live in 300 kilometers outside of the city center and still go to the city center to work every day. We could turn the megacities into megapolis. We have this problem of the megacities that in areas like South America, in Asia, it's becoming a big problem for the quality of life of the people. But what if we have less big areas of population hyper-connected by the Hyperloop? Okay, so safety, of course, is a must. You can create a system that has high speed, but you need to have the safety. But on this, we have been lucky because Hyperloop, by definition, could be the safest the safest mode of transportation in the world. And why is that? Because first of all, we are in an enclosed environment. We are immune to weather, where conditions affect a lot to to the accidents. We are fully automatized, so we don't have errors. We have two tubes, one going in one direction, the other in the other direction, so you don't have problem, of course. But of course, also, we saw very, very soon that we had the possibility to develop this in the way that that should be developed in the 21st century. We can develop the Hyperloop based using new materials, like vibranium, that it's a composite material with integrated sensors. We can use all the smart monitoring of the infrastructure, all the technologies that allow us to have this more safe. And of course, now that we are in the pandemic era, safety starts with the health of passengers. Biometric sensors, advanced air purification, contactless travel, trying to make the travel as frictionless as possible, rapid disinfecting and things like that. But again, because on design, we're talking about a system that a third personal vehicle will be moving the less people in every single capsule, okay? We're talking about 40 to 50 people in the capsule, so it's much less than what goes in a bus, in a train, or whatever. So if you have a problem, you are also, by definition. Let's talk a little bit about efficiency and profitability. For us, as I say from the beginning, it was a must that this system doesn't need to rely on public subsidies. We want to use the public money for education, for other things and whatever, and we want to be sure that Hyperloop will be implemented and developed in countries that they don't have the capacity to subsidize. This here, you are seeing a number that is 2.26 positive benefit cost ratio, that maybe for some of you will say something or not. Just to understand, this is the number that from our last feasibility study that was done in conjunction with NOACA, with the Northeast Ohio Transportation Department, for the connection between Cleveland and Pittsburgh and Chicago. We arrived to this number or relation between benefit and cost. What does it mean? Just you put it on perspective. More than 1.2 is eligible for federal funding in the United States, okay? And we are talking here about 2.2. We are talking about an infrastructure that the return of investment, the period of return of investment could be less than 30 years, okay? And I'm talking about the financial viability of the system, not the social economical impact around the system. I always put the same example, no? Spain is the second country in the world with more kilometers of high-speed rail. It's also one of the countries in the Western European world with a better capex per kilometer. The line that is more successful is Madrid-Barcelona. Madrid-Barcelona, in an independent study made by the University of Valencia, they arrived to the conclusion that if you put together the P&L of the infrastructure operator and of the transportation operator, you need 100 years, to have the return on that investment. Of course, countries and governments invest on that because of the social economic impact. But I'm talking about financial viability. Regarding sustainability, well, we have developed a system that produces more energy than we consume. We have solar panels on top, and we have our passive magnetic levitation that allow us to levitate without having to electrify the track. Okay, this is a technology that was developed in the 90s in Lawrence Livermore Lab in the United States. We take that technology, it's called it in the track. We improve it, we solve the problems that I had at that time, we adapt it to the backward environment, and after that, we have a very, very efficient technology in terms of the cost of the capex, and also the most important, the OPEX. And we believe that we can be a zero-emission transportation when we're talking about, of course, when we're talking about operation. But the Hyperloop system is among the lowest emission transport option available. We have done all the calculations by our sustainable teams, and we are less than 20 grams of CO2 by kilometer. Okay, and but sustainability is not only about that. Sustainability is also to think about how your infrastructure is going to affect to the terrain, it's going to affect socially, and all of that. So we have been working in different solutions to go to urban street sections, typical sections, boring options, to try to adapt the infrastructure. And the most important thing, to create an infrastructure without splitting the territory in two, without splitting the neighborhoods in two, without splitting the public space in two. Okay, so all of this is important, but we need also to think in the passenger. And the passenger, what they need is to reimagine the passenger experience. We have created a system that is human-centric design that has a completely immersive environment with our augmented windows patent technology, and that can give you the access to personalized experience. It's not anymore about if I'm business traveler or I'm tourist or whatever. When I'm the same person, but when I travel with my family or I travel in a different environment, I need different things. It's not only about category. How are we building the Hyperloop? We have talked about the problem, we have talked about our approach to the solution, but how we as Hyperloop TT, we are building the Hyperloop? Well, we are strong believers that there's only one way to do this, and it's through collaboration. We were the first company that was developed was formed to develop the Hyperloop. And at that moment, we put the idea in our platform, in our crowdsourcing platform, and we had like 200 people applying. Today, we've got more than 800 people working in different places of the world in exchange of stock options of the project. We've got more than 50 companies that are equity partners, and we have been featured by Harvard Business School like the new way of building companies. So, and why is that important? It's important not only because you have the people, it's because you leverage on the expertise of the people and of the organizations, of your technological partners. We are a network orchestrator. We are building the Hyperloop together with our technology partners, to bring the Hyperloop to reality. And that's, of course, accelerate our development. These are some of the names, big civil engineering firms, big manufacturing firms, some of the companies that are collaborating with us. We have been also awarded by World Economic Forum like Technology Pioneer. And, and the most important thing, we are doing this and it's happening. I know there is a lot of, there's not skepticism anymore. I remember when we started, how difficult it was to explain the concept. Not anymore. Nobody believes, nobody put in question now that Hyperloop is a technology that is going to happen. It's more about when. Okay. Well, in the when, we also have news. Hyperloop is happening, and it's happening now. We're working. We have our first full-scale Hyperloop system in Toulouse, 320 meters, with. It's a testing and certification system where we integrate all the vacuum system, all the propulsion, levitation, and we are able to test everything, for certification. And we have developed the certification guidelines together with TÜV, and we have been moving on this. I'm not going to put the videos because unfortunately, you are not going to listen to that. Here you have some of the elements, some of the physical assets. You see our full-scale capsule, the full-scale tube, the container that was developed together with Label, the inventor of the vacuum pump, one of the companies that developed the low-pressure environment in the CERN. The valves, that controls, every section of the Hyperloop. Every 10 kilometers, we will have different sections, okay, for the vacuum system. And, in parallel to this, from the beginning, we thought that was not only about developing the technology. We needed to create an environment, that allowed the technology to be implemented. So in parallel to working on this, we were working with Munich Re, the biggest reinsurance company in the world, to do a complete risk assessment. And they did a public statement saying that the technology of Hyperloop TT will be insurable. We worked with TÜV in the certification guidelines that later on we have shared with the European Commission, with the Department of Transportation of US and the Department of Transportation of Abu Dhabi. And, we are helping and being with our colleagues working also in the pathways of transportation and everything that is related to the net council in the States. Okay. So here you have a picture of our actual premises in Toulouse, And in parallel to that, we thought also that there was a good opportunity for cargo. And of course, cargo is about parcels, it's about it's about the possibilities of being fast, but it's also about containers. A lot of the cargo in today's world is still being moved by containers. So we created a joint venture with the Hamburg Port. Hamburg Port is the port of the world that has they developed the first fully automatized container terminal. And they are very good in port operations automatization. And we create a system with them, Hyperport, that basically the whole idea of the Hyperport is to be the Hyperloop of the containers, plus the interface between Hyperloop and the port operations. Some pictures here. We are in the process of developing this, and we want to create a demonstrator, a physical demonstrator in the port of Hamburg, that will come, and with the idea of also having a last mile solution. Okay. In addition to that, we have been working very hard during the last 2 years in Abu Dhabi with our partner Aldar in trying to develop a system, a passenger system, 5 kilometers. We will create an advanced mobility center plus and 5 kilometers track. This we have finalized together with Darren Handasar, the biggest civil engineering firm in the Middle East. We have finalized the concept design, and we are now approaching the next phases of this Al Gadir Experience Center concept. You see here the oasis of the future, with how will be the experience center in the 5 kilometers. What is the idea here? The idea is to show to the world not only that Hyperloop works and the technology works one day, no, that the technology works in a daily basis, is reliable, is efficient, and all the assumptions that we have said about CapEx, OpEx, operability of the system, maintenance levels, and all of that will be demonstrated on these 5 kilometers. And of course, it's also important for us to move towards commercialization. No? In that, we did a long time ago a big feasibility study that was done together with the government of Abu Dhabi, with the Department of Transportation, to connect Abu Dhabi to Al-Ain, and it's a project that we expect to be.
Hi, Andres. Just to let you know that we're running short on time.
Yes.
So
okay, I'm finishing. I'm just finishing. And together with that, we have this feasibility study that we have done together with NOACA for the progress towards the first US road, Chicago, Cleveland, Pittsburgh, with a 5-year implementation timeline. We are now starting the environmental study. This is the different routes that we analyze. And just in addition to the fact that in this system, we could have like 25 years for the return of the investment, we could create 47.6 billion in increased income, property value increase, and expanding the workforce. We are a global company with global presence. We are in the US, we are in Europe, we are in the Middle East, we are in Brazil, South America, we are in every place. And we try to localize our solutions, to the area, and we try to work together with the ecosystem of every area where we are in the world, trying to develop the Hyperloop together with our partners. Thank you very much. And basically, that's my presentation. Thank you.
Thank you very much, Andres Alian. Some really good examples of collaboration, both within the company with the crowd-powered ecosystem, but also externally with people like Munich Re and development of certification guidelines with TÜVSUD. Thank you very much. Our last speaker today is Diana Zhu. She is Senior Director of Global Alliances and Policy at Virgin Hyperloop One. Virgin Hyperloop One is one of the key Hyperloop developers based in the US, and as the name suggests, obviously Richard Branson is a key investor and chairman of the company. So I'll pass over to you now, Diana.
Good morning, everyone. It's great to be a part of the Transportation Innovation Online Conference. I'm Diana Zhao, Virgin Hyperloop's Senior Director of Global Alliances and Policy, and I'm joined today by my colleague, Bruce Kemp, our Director of Safety, Regulatory, and Certification. It's a pleasure to be here to talk to you about Hyperloop and about our company, Virgin Hyperloop. A lot of people ask me, what is a Hyperloop? What's the technology and how does it work? But let me start today by telling you about what Hyperloop could do. Imagine if we could transform the way distance is measured, that instead of taking more than 3 hours by train to get from Paris to Amsterdam, or almost 4 hours from Amsterdam to Brussels, what if you could shrink that distance to go from each of these cities to another in about 34 minutes or less? Imagine what that would do in terms of being able to open up new markets, improve accessibility and mobility, being able to live in one city and work in another, while returning home to your family every night. Virgin Hyperloop is building exactly this. It is a value proposition for the 21st century. We're building a Hyperloop system. Now, what is a Hyperloop exactly? Let me talk about a couple of key features. The first thing everyone thinks of when it comes to Hyperloop is the speed. So yes, the Hyperloop system can go fast. Our system can propel passenger or cargo pods at speeds of over 1,000 kilometers per hour. That's 3 times faster than high-speed rail and more than 10 times faster than traditional rail. But speed is not the only way in which Hyperloop is different. The system can also operate extremely efficiently. The passenger will experience direct and on-demand transportation. There are no timetables. Several pods can depart per minute, and the system does not require stops at every station. Every journey is direct. It's also safe and comfortable. The system delivers airline speeds, but with the same acceleration rates as rail. A central command and control system ensures safe and reliable passage throughout the network. The nature of the tube itself functions as a safe separation of the vehicle from its surroundings, ensuring that there are no at-grade crossings as there are on rail. And finally, sustainability in today's world is not a nice to have. It's absolutely a requirement for transportation that moves us forward. The system is entirely electrically powered, and so there are no direct emissions. And over its lifetime, the system will have a lower environmental impact than other modes of mass transportation. Now, let me shift to what we're doing at Virgin Hyperloop. We are delivering results in years, not decades. We're a company of close to 300 full-time employees, a majority of them engineers, both on the hardware and the software side, technicians, machinists, even artificial intelligence and machine learning specialists. Our headquarters are in Los Angeles, and we also have a test track in Nevada, which you see here. It's 500 meters long, the world's 3rd largest vacuum structure, and we have been testing on it ever since the middle of 2017. In December of 2017, we reached speeds of 387 kilometers per hour, the only Hyperloop vehicle to have achieved autonomous high-speed propulsion and levitation in a vacuum environment. And since then, we have been optimizing on the system and performing numerous tests. The value that we are creating with Hyperloop is clear, and regions around the world are interested in bringing this technology to their communities. Let me talk about a few of them. What you see here is the work that we're doing in Ohio. We've partnered with MORPC, which is the Mid-Ohio Regional Planning Commission, to study a corridor connecting Chicago to Columbus to Pittsburgh. Today, this journey is only accessible by driving, which takes nearly 7.5 hours, or by flying, which takes 1 hour and 45 minutes. Hyperloop can make this journey in just over an hour. MORPC has seen the transformative value of Hyperloop in bringing Columbus closer to cities like Chicago and Pittsburgh, accessing jobs and talent in those areas, and it has just recently completed a feasibility study for this corridor. In India, we have been working with the Maharashtra state government on a Hyperloop corridor connecting Mumbai to Pune, 2 of the largest cities in the state and in the country. A journey that currently takes over 2.5 hours by car will now take less than half an hour. In India, as well as in Ohio, these are both examples of regions that are invested in making Hyperloop a reality in the very near future. A critical step towards commercialization is the certification of the product. Every time you step onto a plane or onto a train or in a car, you have faith that the technology has been approved, checked, and certified by somebody who knows what they're doing and has the authority to say that this technology is safe. Well, we are building the place where this can happen for Hyperloop. Over the past year, we've been searching for a home for what we call the Hyperloop Certification Center, or the HCC. The HCC will help Hyperloop achieve key technological milestones like faster speeds, turning, and switching. A longer track that at least 6 miles will help us achieve this. It'll also help us achieve key safety milestones like creating an international framework for safety certification. In addition, the HCC will create thousands of jobs on the forefront of a new Hyperloop industry. And our goal is to achieve certification by 2025. We're also really excited by the progress on the regulatory and policy front. In the US, USDOT issued a guidance document called Pathways to the Future of Transportation that provided a great deal of clarity on the regulatory path forward to get Hyperloop certified. It clearly stated that Hyperloop falls under the jurisdiction of the FRA, or the Federal Rail Administration, and also established that Hyperloop is eligible for federal funding programs for both the construction and planning of projects like in rail. This is a huge step forward for the industry, and it is enormously exciting. In Europe, we are also heartened by the work that has been undertaken by DG Move and Shift to Rail. Virgin Hyperloop has been a part of numerous workshops held over the past 2 years by these two agencies that have led to the establishing a baseline for safety certification, system definition, and the functional blocks of a Hyperloop system and safety requirements. DG Move is now also carrying out a study to evaluate options for the safety regulatory approach for Hyperloop, and we're excited to be a part of that. These regulatory advancements across both Europe and the US provide clarity and guidance on aspects affecting the design and deployment of Hyperloop technologies, and we are extremely excited to see where they go. I'm going to just end with this. The Hyperloop is not a dream. It's not something that will happen in 20 years or even 10 years. The Hyperloop is real, and we've built it. We're beginning to commercialize it. We're beginning to develop policies to support it. And the potential impacts of Europe and for the world could be extraordinarily transformative. Bruce and I look forward to your questions. Thank you very much for your time.
Thank you very much, Diana. It's really interesting to see the pace of change that Hyperloop developers are working towards, and also that the regulators are doing lots to support the industry moving forwards. Just to let you know that Diana is unable to make the Q&A today. So instead, we're joined by Bruce Kemp, who is the Director of the Global Safety and Regulatory Compliance at Virgin Hyperloop. So welcome, Bruce. He'll be happy to answer any questions on behalf of Diana and Virgin. So thank you very much for everybody. There was really interesting presentations. I hope everybody would agree. We're now going to move into the Q&A session. So if I kick off with a question, let me check. Let me just find a good one for you. Okay, from Alistair Aiken, what is the political appetite or support? What political appetite or support is there for progressing the concept to the next stages quickly? And I'll start with Bruce, seeing as you've not had a chance to speak yet.
Thanks, Roz, and thanks for your question, Alistair. I think there's an enormous amount of political appetite right across the world. Whenever we go to talk to people, obviously the first stage is to meet with the state, local, and national governments in the countries for which we all work. And all the companies are obviously doing this at various stages in various parts of the world. But there is an enormous appetite. There's an appetite for economic benefits. There is an increasing appetite now because in a post-COVID environment, governments need to spend more money on infrastructure development. We talk about sustainability. We've all mentioned the energy efficiencies and sustainability of the Hyperloop system. So governments are extremely interested to capture that and talk to us, obviously, about that. And largely the benefits in which it brings society. You are connecting people to cities that were far apart, and now we're talking minutes. Diana mentioned a moment ago, the Mumbai-Pune journey takes a little under 3 hours by car. We're talking about that journey in 25 minutes. Imagine two cities of 25 and 9 million people being brought together in just a short period of time. You can live in one easily and commute to the other. And that's what governments are primarily interested in, the speed, the efficiency, and economic benefits for which Hyperloop brings to countries all around the world.
Perfect. Thank you, Bruce. Mars? You're on mute. We can't hear you, Mars.
Oh, no.
Sorry, we can hear you now, I think. Oh, no, we can't. I'll move on to Eva. Okay, Eva?
Yeah, I think there's a lot of interest in general from the perspective of the rail industry, and we can see in the UK as well. With for us, for students, it's more of us being engaged, not talking directly to governments, maybe, as we're not in the position at the moment, but we are talking to, for example, we did talk to the rail industry in Scotland briefly. They are very keen on hearing more about the industry of Hyperloop, and how Hyperloop can actually contribute to the society, because I do think that especially in the UK, having like a vertical connection between the major links in the UK, I think it's a highly important thing to have, and it's something that would really benefit, especially now when you think about it. We do have railway systems that connect Edinburgh and London, for example, but then it takes you 5 hours to get there. If you could get there within 40 minutes, this is something completely different. So it is something that is of high interest to all the governments, I would imagine.
Perfect, thank you. Andres? You're on mute.
Okay. Can you hear me now? No?
Yeah.
I think that Bruce has summarized very well. No, right now we are in the middle of this sustainable Greta wave, and we are in the post-COVID area wave. No, and both of the two things help us to, because the governments need to create jobs, robust economy, and they need to invest in infrastructure, and they need to invest in sustainable infrastructure and infrastructure that is prepared for the post-COVID environment. Okay, it's helping us. I would like also to say that there has been two very important things that has happened lately. One, in the European environment, we are working with DG Move, but the Parliament, the EU Parliament makes a motion for the Commission to take in consideration Hyperloop as a solution for the short-haul flights. Okay, that was really important. But second, in the US, the Department of Transportation recently described that Hyperloop was eligible for public funds as a technology in itself. Okay, so I think that these two big public endorsements for the two big areas where regulation and transportation is developed in the world are really important for all the Hyperloop community.
Perfect. I think we've lost Mars, so oh yeah, hello Mars, are you back? Hi Mars, can you hear me? Mars? No.
Okay, let me try. Can you hear me now?
Yeah.
Oh, thank God. Incredible. No, I have very little to add actually. I think the main extra thing I wanted to say is that it is also crucially important for the government that this is a public-private thing, right? So the government is also not able to really lead this either. So it really, for them, it's very important that private partners are also working together, and that something comes out of this. And that's at least something that we've seen very much as well. But also interesting is that you actually see a little bit of competition between a public sector as well, right? I mean, Virgin is doing something also now with the where do you place sort of certification sector? We did the same with our center, where you have sort of competition between public sector even. So how can I pool this into my region? So yeah, there's definitely a lot of appetite.
Perfect. I'm just going to tell you the results of the poll before I forget. So we ran a poll to see if people thought Hyperloop technology was too futuristic to become a reality for passenger travel. And the results of the poll are 56% said yes and 44% said no. So they're pretty much sitting on the fence in terms of whether it's too futuristic or not. So time will tell. Right, so moving on to another question. This is a question from Helen Goddard for all panelists. How can necessary passenger security checks be established and still maintain the very low travel times that you're promising? We'll start with Andres for this one.
Well, I think that there is a lot of things that we do today in the airport that can be done even at home, So you can go through, checking the people while they walk. There is new technologies, there is seamless ticket experience, that can be provided. I think that, again, we are still doing a lot of things. So there is a lot of opportunities of creating a seamless travel experience. We always talk about the naked passenger. In the ideal world, you would be able to travel in the Hyperloop fully naked. Well, ideally without some underwear, but, and you don't even need your phone to go there. Biometric sensors, a lot of opportunities, the technology is there. It's just about application of the technology and breaking with the legacy that we have.
Perfect, thank you. Bruce?
Yeah, I think it's a good question. Thanks for asking, Helen, too. Artificial intelligence plays a really important part here. There's a lot of systems in a lot of transport sectors around the world already in use. So we're not inventing, that much new whilst exploring new options around security. So using artificial intelligence, obviously, to develop and enhance security systems, make our systems safe. We talk about an on-demand system. So it's not rocking up for a system that operates from a timetable. It's you pre-program your journey using a smartphone device. You turn up, you board your vehicle, you go to your destination, and you arrive in 25 minutes or whatever the case may be. They're the cases that we're exploring, obviously, through the uses of artificial intelligence, and we are putting this to use through actually simulating the systems in a real life environment. So that's a significant step forward for us to demonstrate our systems that are one, if not comparable, if not better than the current systems in airports and in the rail environment.
Perfect. Anything to add, Mars?
Yeah, just a very short addition. I already showed a little bit about our study with Schiphol. Obviously, we've been looking very much also at airports, how to integrate it into an airport and all the security there. And interestingly, they already have all the concepts to do this much faster. They already have all of it. We don't have to come up with anything. The problem is that there's so much legacy already, and they see this actually as an opportunity. Hey, now we can use these in a new system. So that's I think we are not focusing on it because it's more there, but I think that's probably we'll find out ways to do that. Yeah.
Okay, perfect. Anything for you, Eva?
No, I think everyone pretty much summed everything up. I think the only thing with planes as well is that usually, the concept of Hyperloop is that it's a constant movement as well. Right in airports, you have these waves of people coming in for each plane journey, whereas in the Hyperloop system, you'd have constantly moving pods. So that would smoother up the whole process as well, I believe.
Perfect, thank you. Okay, we have a tricky one from Rona Rashmani. Can the panel expand more on the safety in extreme situations, i.e. fire or earthquakes? So I'll give that one to Bruce, I think.
Thanks, Roz. Great question. We're always asked this question. As we've all said, safety is our first and fundamental value with building this system. It has to be safe. We have to demonstrate that it's safe. We have to have the systems and processes in place. And it goes hand in hand with the standards that Mars mentioned earlier as well. Thanks for the question, Rona. It's not a very simple one to answer. We take the best of what's in existence right now. We build our systems using the fundamental building blocks that other industries use. For instance, we apply systems, standards, and the regulatory approach that's adopted in rail and in aviation. We do a combination of both. We follow existing standards right across that spectrum. We also reference space standards. Obviously, we've spoken about a vacuum environment that plays hand in hand with technology that's referenced in space, but also you start simple, find out what the existing processes are. So we've got European rules at the moment governed by EN 50126, 7 and 8 to develop our safety systems and our safety approach. We are aligning our systems with those. We are validating our systems, for instance, using an independent safety assessor. So it's not just us saying that it's safe. We need to demonstrate independently from us that our systems are safe. So we do that through an ISA. And obviously, we start our journey, identify the risks and the controls, building our preliminary hazard analysis that will one day turn into the operations and maintenance hazard log, as you would see in a railway operating environment.
Perfect, thank you. Mars?
Yeah, I mean, we're joining those sessions also at the European Commission. We're sort of in the same process with as Bruce is saying, so we fully support that as well. And I think the last thing just too important to note is that this is really what those test facilities are about. We're already doing all the finite, the failure mode effect analysis and coming up with concepts how to mitigate those. And these test facilities that the different parties are all about showing that in all those cases, we actually have a solution that makes it safe.
Perfect, thank you. Andres, anything to add?
Well, I'm not going to go too technical because, of course, we could talk about different elements and different scenarios, and not. We, as Bruce has said, we're working together, also in this European environment for the safety regulations and all that. We created this safety certification guideline with the people of Tursud, one of the top ASA companies in the world, in transportation. And very curiously, the risks that are the most important ones are not the most difficult to solve. Okay, a lot of the technology is already there and possibilities that are there. What is important, is to also not forget that by definition, the Hyperloop system is much more safer, by definition, than other systems in the world, because at the end of the day, again, you are in a closed environment, you are immune to weather, you are immune to personal or to problems, with the manipulation of the people and things like that. And at the end of the day, when you do the risk analysis, like always, and like in any simple infrastructure in today's world, the biggest hazard or the biggest problem could be cybersecurity, like always.
Yeah, it's a big challenge for any transportation. Okay, Eva, anything for you?
Just to add as well that as everyone has already mentioned as well, there isn't, there are lots of technologies that can be applied as well. So for example, being in a Hyperloop tube wouldn't be, it would be very similar to being in a tunnel. So if there is an emergency situation in a tunnel somewhere, it will be quite a similar situation that you have to get out of there as well, except for the fact that there is a low pressure environment. So that's the only thing, but there is technology at the moment that could be used to solve that problem. So as has been said before, it's not actually such a new thing that needs to be introduced. It's just adapting things that are already in place to make sure that everything's safe.
Perfect, thank you. Okay, we have a question from Michael Haynes at Transdev. Is there a minimum distance between stations for this concept? And I'll go back to you, Eva, give you a chance to answer that one first. So minimum distance between stations.
There isn't a minimum distance, so it depends how you think about it. Because in theory, yes, the Hyperloop is a really fast mode of transportation, but it doesn't need to necessarily meet that maximum speed every single time it goes between two cities. So I would imagine there is a minimum distance that is that could be given off the bat. However, obviously there will be calculations involved with planning every single route with, how much acceleration is needed, how much deceleration is needed. It will be, a lot of thought will need to be given with every route planning and every, even the curves in the route. So for example, if you give it in a straight line, it's going to be quite easy. If you want to connect 3 cities, for example, then you need to plan the route quite a bit more in more detail. But I would imagine that there isn't a specific answer to this question without diving deeper into the specifics of the location.
Perfect, thank you. Mars?
Yes, I think one important mindset, and it also came back shortly in the end presentation, is that you can think of Hyperloop very much as sort of a super highway where vehicles merge out and in. That gives it a lot more flexibility than having to stop at every station in between. So don't really think about stations as stops, but rather think about the interval between where stations could be. For some places, we go 500 kilometers without meeting anything in between, you just go on. You probably have a slightly higher average speed, but there's also places where we see that there are station connections even down to 25 kilometers. So it is really a spatial implementation versus operational scheme question that is looked at different places. But there are places where short distances about 25 kilometers are also in place.
Perfect. Bruce?
Yeah, I think it's a great question, Michael. Hyperloop is a very flexible technology as well. We can operate in a transit environment over much shorter distances. We can do an airport to airport connector, connecting a domestic airport with an international airport, or we can do vast distances. We can do inter-country travel. So the technology that we're actually building is very flexible, catering for the demand of the particular countries that we might potentially be working in. So that makes it even more exciting.
Perfect. And Andres?
Well, I think that my colleagues has really explained this very well, and I don't have a lot to add. I'd say just that I remember one conversation with a chief strategy officer of a big rail and transportation companies that he was saying to me, well, if you are able to do the big, you can do also the more, you can do also the less. No, if you are able to move people 1,000 kilometers in 1 hour, you can also move them 20 kilometers in minutes. No, so I don't see that. At the end, it's a question of rationality, and it's a question of economical balance. If it makes sense or not, doesn't make sense, because on the traffic and it's feasible or not, economically feasible, the implementation of the technology in that particular route. Perfect.
I'll do one last question. I might not have time to get everybody to answer depending on the time, but let's have a look. One from Bella Josa at Rail Projects Victoria. What is the energy requirement for reducing the vacuum for the concept? I'll give that one to Mars.
Okay, yeah. It's good to keep in mind that sort of you pump down the pipe sort of once. Of course, you do it often in maintenance cycles, but you pump it down once, and then the pipe stays at a low pressure. So then afterwards, vehicles go through, and at that moment, you only have to make sure that you sort of pump away the air that leaks into the system. And as we identify, almost all the air that is leaked into the system is at the airlock, because there you have vehicles constantly, or air ducts, where you have the vehicles constantly getting in at a station. There's a sealed door, people going out and in, and then you always have a little bit of air leaking back into the system. If you look at the amount of energy that you need to pump that out versus the amount of energy that you still need to travel with the vehicles, at the operational pressure that we're now working at, which is about 100 pascals, or 0.1% of the atmosphere, then the amount of energy that you need for the pumping is about less than 10% of the entire energy usage. And the entire energy usage is again about 10 times lower than that of aviation. So in the grand scheme of things, the energy usage of the pumps, we don't expect that to be one of the largest ones. And of course, in all the testing, we'll still have to find out what the perfect operational pressure is. So maybe the ratio changes a little bit, but in order of magnitude, this is our expectation.
Perfect, thank you. Bruce?
Yeah, I think I'd agree with Mars on that one. The energy required to carry out that pressurization activity is probably 9 to 10% of the overall energy required. Once we get to those levels, though, we can maintain that with an enormous amount of efficiency. We also have the capacity to depressurize and repressurize in a reasonable amount of time, using a reasonable amount of efficiency as well to cater for those emergency situations as well. I think that's important to recognise. But thanks, Bella, for the question. It's not an easy one to answer. It's not a very simple one to answer. I think we could sit here and talk about that for quite a while. But it is, a part of the overall system, but not a significant part.
Yeah.
Anything to add, Eva?
Not much from me. I think everything was pretty much covered here.
Okay, what about Andres?
Well, I think that they have answered this question very well, my colleagues, and I have the similar idea. It's not a significant element, of the energy consumption in the Hyperloop system. It's there, okay, but it's not the most significant at all, by far. Okay.
Perfect. Well, thank you very much for everybody today. Eva, the presentation that you tried to present that didn't work has now been put online, so everyone should be able to access that now. So thank you very much to the presenters and for everybody to attending today, and obviously for your responses to the Q&A as well. I think it's been a really thought-provoking session, and what is a very promising technology if it comes to fruition. So just some kind of key takeouts from my side. So going back to that title of today's session, which is Hyperloop a reality for passenger travel? We've heard that there's obviously an increasing demand for passenger and cargo transport over the coming years. And obviously Hyperloop promises to kind of offer a potential sustainable solution in terms of things like cost, efficiency, speed and capacity. But obviously there's different dates kind of being bouted out there, but I kind of think that the commercial passenger system perhaps isn't going to be with us for at least another decade. Some might argue differently. And there's a lot of questions still to be answered in terms of issues related to safety, legislation, economical and technical. So I think for the next 10 years, we'll see Hyperloop companies testing their concepts to identify which ideas work best, and hopefully we'll see some integration as the years go on to obviously try and standardize the concept. And then obviously in parallel, we're seeing work to develop the regulatory framework and standardization so that how Hyperloop can obviously move from a concept at this stage to a reality in the future. So I think that's everything from our side. I think we've run out of time, so I'll say bye for now. Thank you everybody for attending.
Thanks, Roz. Thanks everyone
Thank
for your
you very
questions.
much.
Bye-bye.
Yes, thank you everyone.
Bye-bye.
Bye-bye.
I just wanted to briefly, just to summarise as well, great session that was, and it's really exciting to see where the future of Hyperloop will take us. It's definitely a concept to look out for, and really intrigued to see how we move forward. I also just wanted to take the opportunity to recap on some of the other sessions that we've had over the last few days during the Transport Innovation Summit. We've heard from some fantastic experts who have provided some really informative and engaging presentations focused on a lot of different developments within the railway sector. For instance, how to move forward with digital transformation of rail freight, and the importance of carbon smart railways and reaching industry environmental goals, plus improving the passenger experience, and how big data is playing a part in intelligent infrastructures. So don't worry if you've missed any of these fantastic sessions, as you can watch them all back on demand when convenient for you. You'll find all the links in the platform, and where you can also view the rest of today's agenda and for the rest of the week. So please make sure that you make the most out of your attendance. Please join the sessions, and please ask your speakers your questions, and contact each other on the platform as well. So thank you everyone, and goodbye.
Thank you.
Bye for now.
Bye.
Thanks.
Thank you.
Bye.
Goodbye.